In this video, we are going to go and see the double displacement reaction. So it's called as double displacement reaction. So double displacement reaction is where you swap out your partners. Okay, so if I have AB plus CD, let's take AB plus CD, and I'm going to write it in terms of cations and anions. Say if A forms plus charge and B is an anion, and if the C is going to be plus and if D is going to be negative. So let me make this one blue. Okay, so what is going to happen is swapping out the partners means this positive will go and grab this anion and this cation will go and grab this anion. So double displacement is just like you ended up swapping the partner. So your new compound will be AD plus CB. Got it? So double displacement is just swapping your partners. Go and grab the other anion if you're a cation and go and grab the other cation if you're an anion. So this is a basic double displacement reaction. So in order to write the double displacement reaction, you need to know how to dissociate the ionic compounds, and we just learned in the other video how to dissociate the reaction. So in double displacement reaction, so let's learn with how to dissociate and write the product side. So I'm going to say I have potassium iodide in aqueous solution is reacting with lead nitrate. So this is lead nitrate, PbNO3 twice. You need to write the product, and I'm going to tell you this is a double displacement reaction. If it's a double displacement reaction, you need to swap the partners, right? So for that, we need to figure out which one is our cation in both the reactants and which one is my anion in both the reactants. So if I say potassium and iodide, which one is your metal? Potassium. So that will be your positive charge. In lead and nitrate, which one is your metal? Lead, right? And the nitrate is going to be your anion. So I'm just going to highlight my cations and anions with different colors so you will be able to know. So now we need to split them into cations and anions. Potassium belongs to which group? Group 1. So potassium will have a charge of +1. Iodine belongs to which group? Group 7. So iodine will have a charge of -1. Then you're going to take Pb and NO3. Over here, you don't know the charge of Pb belongs to a transition metal, says lead belongs to C. Lead, where does lead comes? Right over here under the group 4, right? So this is where you can see the lead over here. It's not even like in here. So it's actually not even in the transition metal. This comes under group 4. So when you look into the group 4, lead comes over there. So we don't know the charge of the lead metal, but we have PbNO3 twice. So what we can do easily, following the exact same thing what I told in the previous video, take this 2 and you can easily crisscross and put that charge on top of Pb. So I'm going to put Pb plus 2. That means NO3 is going to be supposed to be -2, but how many NO3 I have here? How many? 2. So I'm going to put 2 NO3. So each NO3 will have a charge of -1, or take this one over here and crisscross and put it on top of NO3. So NO3 or the nitrate is going to have a -1 charge. So you have nitrate. You don't need that 2 for swapping the partners. This is your anion, this is your anion, and for cation it is going to be potassium +1 and Pb +2. So what is going to happen? This potassium is going to go grab this nitrate and this Pb is going to go grab this iodine. So I'm going to say for here K plus and NO3 minus. Don't worry about that 2, okay? This is just you have 2NO3 at the end of the reaction. That means the balancing might be needing for this equation. But if you just look into cations and anion, you have +1, -1. They can easily get cancels out. So one of your product is going to be KNO3 plus, what is my other? So in here you have Pb plus 2. So let me write this one right here. Okay, I don't have space. So I have Pb plus 2 and I have I minus 1. In here you have +2, cannot cancel out with the -1, so you need 2 iodine, or take this 2 and put it underneath, and take this 1 or put it underneath. So there's 2 ways to write this one. Pb is Pb plus 2. In order to make a neutral compound, you need 1 more iodine, right? Because this is +2, -1 does not cancel out. What is +2, -1? You still have 1 + 1 remaining, so you technically need 2 iodine. So your other compound is going to be PbI2. Got it? So this is how we actually crisscross and write the ionic compound in double displacement reaction. So let's do one or two more problem. I'm going to take, say, K2 potassium sulfate, K2SO4, and I'm going to say barium nitrate, BaNO3 twice. Both of them are in aqueous solution. Let's see how can we write the double displacement reaction. This will have one cation and anion, and this compound also will have one cation and one anion. Let's keep it simple. Let's take this 2 and put it on top of SO4. You only have one SO4 here, so take this one, put it on top of potassium. Or potassium will always form +1 charge because it belongs to group 1. And how many K2 I have here? It's going to be 2K+. SO4 is always going to be -2. You will learn few polyatomic anions charges and from this video itself. Then you have barium nitrate. Barium belongs to which group? Group 2. Or you can take this 2, put it on top of barium. So it's going to be barium +2. That means nitrate. You have 2 nitrates here. It's going to be 2NO3. Each one will have a -1 charge. You have nitrate and sulfate as the anions. And you have potassium and you have Ba+2 barium as your cations. This cation will go and grab this anion, and this cation will take and grab this anion. So how do I write? I have K plus and NO3 minus 1, right? So these guys will cancel out very easily. So it's going to be KNO3 is going to be one of your compound. The other one is going to be Ba+2 and SO4 -2. This is also equal charges, so it will cancel out. So your other product is going to be BaSO4. Got it? And how do I write one more? Let's do one more problem. PbNO3 potassium nitrate, PbNO3 twice, and ammonium carbonate, that is going to be NH4 twice, CO3. How do I write the double displacement for this one? Split them into cations and anions. Same thing, you know lead nitrate by this time. Pb will have a charge +2. I have 2 nitrates here, so it's going to be 2NO3, and each NO3 will have a charge of -1. Then only it can form a neutral compound. The same way you have NH2, you can take this 2, put it on top of carbonate, and you only have one carbonate here, so take this one and put it on top of ammonium. Or ammonium will be always +1 charge, and you have 2 no, you don't have 2 carbonate, but you have 2 ammonium, so it's going to be 2 times, right? 2 times ammonium ion. That means carbonate will have a charge of -2. So you have ammonium as one of your cation, lead as one of your cation, and your anions are going to be nitrate and carbonate. So when you crisscross, that means this lead will go and take this carbonate and this ammonium will go and take this nitrate. So you will have Pb plus 2 will go and take CO3 negative 2, equally cancelled out. So your compound will be PbCO3, lead carbonate, plus the other one is going to be NH4 plus will join with NO3 minus, again plus 1 and negative 1 cancels out and you get the compound is ammonium nitrate or NH4NO3. And in the next video, I will tell how to figure out which one is your precipitate for a precipitation reaction. That will be in the coming videos.